Alright, we're in section 7.1 and we're talking about sequences. Before we actually review the definitions and formulas for arithmetic and geometric sequences, let's talk about sequences still in terms of more general things that apply to many sequences, all sequences. Okay, so there's two different types of formulas for sequences. We can have what we call a recursive formula, or what's called an explicit or general formula or nth term formula. Okay, so a recursive formula defines a new term based on one or more of its previous terms. Let's look at these examples. So A is going to represent numbers in the sequence. The n in the A variable, so A sub n, represents the term number of that term in the sequence. So A is a term, n is the term number. Okay, so this particular sequence has been defined as A sub n is equal to A sub n minus 1 plus 2. Okay, so that's our recursive formula right there. And there's a comma, and then we have some other information that we needed to know. A sub 1 is negative 3. So we already know A sub 1. We already know our first term is negative 3. Now we're supposed to find the next terms using that formula. So here's what we do. We've got the formula A sub n equals A sub n minus 1 plus 2. So the next number we want to find is A sub 2. We're finding the second term. So this one right here is the first term. So they had to give us that for us to start this recursive formula. We have to start somewhere. So this is the first term. That's usually typical of a recursive formula, is that you're given the first term, or at least some sort of term, so you can figure out what to do with it based on the formula. You can't do the formula without having some sort of information about the sequence itself. Okay, so A sub 2 would be the second term, and that's because it's a sub 2. So this is like the name of this term. The name of the term is A sub 2. Like my name is Mrs. Featherstone, or your name is whatever your name is, right? So this is a name for the term that we are finding. A sub 2 is the second term because of the 2. N is 2. So what we're going to do is plug in 2 anywhere where we see an n. So the only place I see an n besides right there at the beginning is I'm going to have a 2 minus 1. Now again, this isn't really a math problem as much as it is a name. A sub 2 minus 1 plus 2. That is simply telling us to take the term defined by 2 minus 1 and add 2 to it. So A sub 2 minus 1 literally means we're taking A sub 1 and we're adding 2 to it. Well, look, they gave us A sub 1. A sub 1 is the name of the term negative 3. So if we're doing term A sub 2 minus 1, we're taking term 1 and we're adding 2 to it. So we're taking term 1, which is negative 3, and we're adding 2 to it. And we get the answer negative 1. That's the second term in our sequence. So far we have our sequence consisting of negative 3 is the first term and negative 1 is the second term. And really, without having to go through this whole process here, you could think, oh, well, I'm just adding 2 to the next number to get the next one. Well, what is negative 1 plus 2? Well, it's 1. What's 1 plus 2? 3. What is 3 plus 2? 5. What is 5 plus 2? 7. So we are creating the odd integers with this formula. This is also an arithmetic sequence because it's adding a value of 2 each time. Let's do another one just to make sure we understand the process. So let's say if we wanted to find A sub 3, that's the third term, we are taking A sub 3 minus 1 and we're adding 2 to it. So that means we're taking the second term, because 3 minus 1 is 2. I hate the way that the program like bleeps all my stuff together sometimes. Okay, so 3 minus 1. And then that's 2, so we take A sub 2 and we add 2 to it. So remember, we just found A sub 2 is negative 1 plus 2. So the A sub 3 value is 1, which we have right here. We're just going to keep adding 2 to get the next number, and that continues indefinitely. Alright, let's look at this sequence here. So we have A sub n equals A sub n minus 2 plus A sub n minus 1. and they've defined a few values for us. We have a sub 1 is 1, a sub 2 is 1, and then we're going to continue forward from there to find term number 3, term number 4, etc. So we want to start by finding term number 3, because we already know term number 2 and term number 1. So let's see how this notation works for the names. So n was 3, correct? We're going to take 3 minus 2 plus a sub n is 3, 3 minus 1. So right now I'm just working with the notation. So the third term is the term of the third term minus 2, and the term number defined by 3 minus 1. So literally that's saying we take term 2 and we're adding term 1 to it. So term 1 was defined as, or term 2 is defined as 1, and term 1 is also defined as 1. So together we find term 3, which is 2. Okay, let's find term 4. Term 4 would mean that we're taking 4 minus 2, which is 2, and we're taking 4 minus 1, which is 3, and we're adding a sub 3, which we just found is 2, and we're adding a sub 2, which is 1, and we're getting the number 3. So far our sequence consists of 1, 1, 2, 3. So we just took the two numbers they gave us to start it. We found the next one, we found the next one. What's happening here? What is this going to keep doing? So we've got a sub 5 is a sub 3 plus a sub 4. So a sub 3 we found here is 2, and a sub 4 we found here is 3. Add those together and we get 5. We're adding the two previous terms to get the next term. This is Fibonacci sequence. So creating a recursive formula for Fibonacci sequence isn't that bad. Now creating a explicit formula for Fibonacci sequence is quite a bit more complicated. Okay, so a general formula or an explicit formula or a formula for the nth term is where all we have to do is plug in n and we can get that term number. I used that example earlier with the square numbers. If we plug in a 10, 10 squared is 100. So the 10th perfect square is 100. And we didn't have to find the first and the second and the third and the fourth and the fifth and the sixth and the seventh and the eighth and the ninth to find the 10th, like you would have to with a recursive formula. Recursive, you have to find previous terms to find the next term. With an explicit, you just plug in the term number, you get the answer. So here is an example of an explicit formula. We're going to go ahead and find the sequence that goes with this. So the first term of our sequence is found by multiplying 2 by 1 and subtracting 5. So that will give us 2 minus 5, which is negative 3. And the second term of our sequence is found by taking 2 times 2 and subtracting 5. So that would be 4 minus 5, which is negative 1. And then our third term of our sequence would be found by going 2 times 3, subtract 5. So that's 6 minus 5, which is 1. I don't know if you recognize what's happening here, but we are getting an arithmetic sequence that's adding 2 each time. And it's just going to keep going up 2 each time. I think we saw this already in our sequences that we were already looking at. So this is a general formula, or a formula for the nth term, an explicit formula. If we wanted to find the 10th number, my gosh, all we have to do is plug in 10, and we would get the number, which is 15. So down the road, 1, 2, 3, 4, 5, 6, 7, 8, 9, the 10th number is 15, and we didn't have to find all the numbers in between to find that answer. That's the beauty of an explicit formula. Okay, so these types of formulas work for almost any sequence. Doesn't have to be arithmetic and geometric, but we're going to focus on those two types. Let's see what we've got here. Definition of a sequence and sequence notation. A function f of n with domain of all natural numbers or subset of consecutive natural numbers. The subscript notation a sub n is often used for function values where n equals 1, 2, 3, etc. Also sometimes written as, sometimes, I can't remember what I had here before I deleted it. I have to go back and look. But sometimes we write it as like a sub n like this. These are also examples of how to write out the formulas. So I'm going to go ahead and quit this video at this point, do a little research.